Hello everyone. Here in this video, we would like to talk about the force on a body in simple harmonic motion. Right? That's the point. Uh, we have derived equation for the acceleration of a body in simple harmonic motion as minus omega square phi, where minus indicates acceleration and displacement are in opposite direction and they're proportionate. Therefore, it is in simple harmonic motion. Now we want to find out force. So to get that force, we know as force is mass into acceleration. I will just multiply the above equation with m on both sides. So ma becomes minus m omega square y. In the case of ma, I can write force can be written like minus m omega square into y. So m is the mass of the particle, omega is the angular velocity. Both of them are constant for a given situation because we are talking about a omega that is of a uniform circular motion. So as m omega square is constant, that constant is shown with a k, where this k is called as, it comes because of the force, so you call it like force constant. So you can rewrite your equation as F is equal to minus ky. Of course, k is constant, so that the body is in simple harmonic motion is another way of representing it. Where what is the k is equal to m omega square. From here, I can further write omega square is equal to k by m. So write further omega as square root of k by m. Omega is angular velocity, that is rate of change of angular displacement d theta by dt. When one rotation is completed, d theta is 2 pi, dt is a time period. So in the place of omega, as we have written so many times, we can write 2 pi by t. That is equal to root of k by m. So I can express time period of a particle in simple harmonic motion as 2 pi into root of m by k, where m is the mass of the particle, k is the spring constant. This is another way of expressing time period, right? In the earlier case, I had derived an equation for time period of a simple harmonic motion. You can represent it, you can find it, you can check it. This is another way of expressing simple harmonic motion in terms of force constant. And for every particular situation, like a simple pendulum, we will have a different formula of time period. We will be talking about that further in the further videos. If you are talking about this force that belongs to a spring, I just want to add you a point here, right? If force is on a spring, SHM automatically K there is called spring constant. So spring constant is a specific case of a force constant. We can use any of these equations. In that case, that T will become the time period of that spring in the oscillatory motion. So any of these equations are quite possible to write, right? So this is how we want you to understand the oscillatory motion. Thank you for watching.